So long far away, there was a galaxy, and there was a school in this galaxy, the best school in the world. It was SNU. Pretend you were a young lad like this fellow. Hi, I'm so cool! And you were walking down Dallas Hall until you met a professor. Hello, my name is Min Jung Kim, and I teach Thermodynamics at SMU. And one of my great students named Tyler Huynh is actually asking you a candy question that I will actually never give you candy for. What? I love candy! So the candy question is, which one freezes faster, hot water or cold water?
It might seem obvious that the cold water will freeze first, but according to some experiments and some studies, actually the hot water freezes first. This is also known as the Mpemba effect. So we're actually going to do our experiment over that, and we're going to do that right now.
You've probably seen this phenomenon before on the internet. When someone throws boiling hot water in freezing cold air, it freezes instantly. It's a beautiful sight, yes, but it's also fascinating how we're still boggled by the conceptual nature of water still. This shouldn't be able to happen. There has to be another variable in play, or if this was true, we would actually have to burn a lot of thermodynamic tables. So the Mpemba effect comes from a man named Erasto Mpemba. He published his results in 1969. He first came out with the hypothesis when he was making ice cream. Yes, ice cream. When he came late to class one day, he wanted to catch up with his classmates. So when he was making ice cream, he didn't let the water cool down from boiling and put it straight in the freezer. Little did he know, he saw that his ice cream froze first despite coming in late.
So right now we're in my kitchen, and to start the experiment we're going to actually have two identical containers. So these are baby containers. We're going to actually fill one with cold water and one with hot water. So hot water, we're actually boiling some water in our tea kettle right here. And for cold water, we're actually going to take some tap water and we're going to put it in the fridge. So let's go do that.
So some history about the Mpemba effect. He wasn't the first one who thought of the idea. Aristotle actually had a quote where he said, "The fact that the water has been previously warmed contributes to freezing quickly, for so it cools soon." Hence, many people, when they want to cool hot water quickly, begin putting it in the sun.
So our water just finished boiling. I'm going to pour out some into 100 milliliters. A little bit more. Just about 100. I'm going to pour that in our jar. And use the rest for ramen. So here are our two containers. The one with blue tape is our cold one, and the one without tape is gonna be our hot one. So let's measure the temperatures right now. Let me get this in focus. So it's just about 74 Celsius. And now let's try the cold water one. And it's just below 20 degrees Celsius. So now we're gonna just put these in the refrigerator. It's so hot. So hot. We're gonna put these in the freezer right above here. And we're gonna actually check every 30 minutes, check the temperature and see if any ice is forming. While we wait, crawfish time!
So the first theory is supercooling. We all know that water freezes at 0 degrees Celsius, but before freezing, the temperature actually drops below 0. This is because ice needs a nucleation site for ice to first form, like an air bubble or dust. So the theory is that hot water needs less supercooling than cold water to form. So our second theory are convection currents. We know when water is cooling down within a liquid, it's because of convection currents mixing the hot region to the cooler region. So since hot water has faster convection current gradient, it will cool quicker even when both gases are reach the same temperature. So the last theory is my theory. So let's say the freezing point is the equilibrium point and both waters want to reach it. So the hot water is actually cooling down faster than the cold water since the equilibrium rate is faster. But who knows? I don't have a PhD in thermodynamics.
So 30 minutes have passed, and remember the blue tape is the cold one and the one without tape is the hot one. So we actually can see some crystals forming right there. I can touch them right there. I don't know if you can hear that, but it's actually cracked ice. While our hot one is not actually any frozen at all. So I think thermodynamics won this round.
So, do you know the answer? Yes, I do. The answer that Tyler taught me is that he's so awesome.